For these next few problems, all we want to do is find the coordinates. So that means the actual ordered pair. Because eventually what we're going to do is graph all of these functions. So we're going to need to know the specific point. So when they say find the coordinates, that means the x and y value. Okay, so remember, when it's the coordinates, when it's the y value, you need to use the regular function. Okay, the extrema, that's what we just found, the relative extrema, they're talking about the max and min. So anytime they're talking about increasing, decreasing, relative max and min, that's always the first derivative that we're looking at. Okay. So the first thing I'm going to do is do like what we did on the last problem and take the derivative. So that'll give me 2x plus 3, that'll go away. And then I'm always going to set it equal to 0, factor if possible, and then solve. So this one, since it's just x to the first and there is not a GCF, that's just going to give me x equals -3/2. So that's what goes on the number line. Okay. Then again, you can plug in a number less than -3/2 to the derivative right here. Okay. Or you can just look at the leading coefficient, which is what I'm going to do. So if you're going to look at the leading coefficient, you always need to start on the right side. Okay. So starting on the right, since the leading coefficient is positive, I'm going to start with positive and then I'm just going to alternate. The only time you wouldn't alternate is if something was squared, like this. So if the squared was outside the factor. Okay. If there was a squared here, this one we couldn't solve, but if the squared was there, you wouldn't alternate. Okay, the only time if the squared was here, you would alternate. The only time you do not alternate is if the entire factor is squared. Okay. So since nothing's squared on this one, I'm going to look at my leading coefficient. That tells me where to start. And then I'm just going to alternate. So we've got decreasing and increasing, okay, which means this is a minimum. So this function has a relative minimum at -3/2, okay, but then I have to find the y value. So you're going to go back to the original equation for the y value. Okay. So -3/2 squared is 9/4. 3 times -3/2 is -9/2 plus 1. Okay. So then I'm just going to get a common denominator. That'll be 9/4. Here I'm just going to do times 2/2. So that'll be 18/4 and then plus 4/4. And then just add and subtract your numerators. So 9 minus 18 is -9 plus 4, -5/4. And that'll give me the y coordinate. Okay. So if they specifically ask for the coordinates, that's when you need to find the y value. If it's ones like these where they just say find the extrema or find the relative min and max, that's when you can just put the x value. So when it says find the coordinates, that's when you know to also find the y value. So if we look at this one, we've got f of x equals x cubed minus 9x squared plus 27x. Okay, so we're always going to look at that first derivative first. So that'll be 3x squared minus 18x plus 27. This one I'm going to have to factor. So first I want to take out the 3. And then now, since this doesn't have a coefficient anymore, since it's a 1x squared, I can just do what multiplies to 9, adds to -6. That would be x minus 3 and x minus 3. So since it's repeating, I'm going to rewrite it as x minus 3 squared. So now that I've completely factored, okay, I don't get a number from this one because it's just a 3. If this had an x with it, then we would get a 0. Okay, but since it's just a 3, we don't get an answer here. From the x minus 3, I get a positive 3. Okay. Now, since this factor squared, that means I'm not going to alternate at the 3. So I'm going to look at my leading coefficient. It's positive. Okay, then on the other side, since it's squared, it's going to stay positive. So if your factor is squared, it doesn't alternate as you go from one side of the number to the other. So that means this function is just increasing the entire time. Okay, so this value right here isn't a minimum or a maximum. So here, if they ask for relative min and max, since it's increasing the entire time, that just means there's no minimums, there's no maximums. Okay, and then let's look at one more. So we have f of x equals 1/4 x to the 4th minus 2x squared plus 1. So our first derivative is x cubed minus 4x. The plus 1 will turn into 0. Then we've got to factor it, so I can take out an x. Then this part right here, you can either solve it using square roots, or if this number is a perfect square, I just factor it with a difference of squares. Okay, but if you solve it using square roots, you're still going to alternate at the +2 and the -2 when you take the square root, okay, because the squared isn't outside the parenthesis. Okay, so if you solve it using square roots instead of factoring it like I did, so if you do x squared equals 4 and get x equals positive and -2, okay, you are going to alternate at these numbers, okay, because the square isn't outside the parentheses. This is the only time you don't alternate, when the square is outside the parentheses. So this time I'm going to get 3 numbers. I'm going to get -2, that'll be the smallest. Then I'm going to get 0, and then I'll get +2. So starting on the right, my leading coefficient is positive. So I'm going to start with a positive. Nothing is squared, so I'm going to alternate at all of them. But like if this had been a squared right here, then I wouldn't change at 0. But since everything is to the first power, we're just going to alternate signs at every single interval. So then we've got decreasing, increasing, decreasing, increasing. So I can see this is a minimum. So I'm going to have a relative minimum at x equals -2. So to find the y value, I go back to the original equation. So this will be f of -2. So I'll have 1/4 times -2 to the 4th is going to give me +16. So 1/4 times 16 is just going to be 4. Minus 2 times -2 squared is 4. So that'll be 2 times 4, which is 8. So that'll be a -8 plus 1. So 4 minus 8 plus 1 is going to give me -3. And then I can see on this one I also have another minimum at +2. Okay, because it's going down, then back up, making that a low point. So anytime you're going down and then you turn around to go up, that's going to give you a low point. Okay? So when I plug in 2, that's going to give me the same number. So here, plugging in +2 to the equation is going to give me the same number as -2. And then at 0, I'm going up, and then I turn back around. So you're getting higher, and then when you turn back around to go down, that's going to make this a maximum. So our relative maximum is at 0. And so then when I go back to the original equation, that's just going to give me 0 everywhere I have an x, and I'll just end up with 1 for my relative maximum.